Hey everybody, so let's do a coding interview practice using this blind essential list of 75 LeetCode questions. Um, so today I'm gonna use two sum and three sum as a follow-up to do some simulation in the real coding challenge. So I'm gonna start with two sum. So I assume that in the real interview, we're gonna start with some easy question, and then we're gonna gear towards to more medium or slightly harder questions. So let's begin. So to some, so given an array of integers, nums, and an integer target, we need to return indices of the two numbers such that sum is gonna be equal to the target. So goal is to uh, So I will always start with these settings because we need to make sure constraints are also clear. So the goal is to return, so we have to return list of integers, ij, where nums of I plus nums of j is gonna add up to the target. So that's the goal, right? Um, so for example, 3 to 6, let's do one example. 3 to 6, and the target is equal to 6, and then we need to return uh, 2 and 4. uh, so integer is 2 and 4. Since nums of 1 plus nums of 2 is 2 plus 4 equals to 6. So that's to sum. Let's think about constraints. uh, I'm pretty sure we should have a few uh, constraints. So first of all, nums are not sorted. Nums are not sorted. I'm not sure how does this gonna impact. And then we have duplicates is possible. Duplicates are possible. Uh, so we can also return duplicates, and then there should be only valid one answer. So constraint 3, although my typo, constraints are only one valid answers. Uh, do we have any empty input? So const const 4, no empty nums. Okay, so this means no edge case, no edge case for empty input. Um, so how are we going to solve this? I'm pretty sure we can think of multiple ways, but so first, uh, so I'm pretty sure we can use for each num. Uh, for each num, we're gonna create a set. We're gonna create set, uh, and if target minus nums in the set, then return and then return. So this is a list of for each I. So this is a tuple of index I and the num. We want to return I, um, and and the and the j, where this comes from target of nums. Okay. Um, so yeah. So the runtime of this should be open because we only traverse for each element, and then using the dictionary, uh, getting the element it's constant. So we can definitely use that. So the second way is to use so for each num check if target minus num in in the in the num of I plus 1. But this is too slow because we're not using dictionary. So this can take over n square because for each num, it's just repeating, just traversing again and again in the nest. So this is too slow. What about if we sort? So if we sort, which means we're gonna take low as a lower bound n log n. That's the sorting help. So if we have 2, 7, 11, 15, um, and then use the dictionary, use dictionary and check. That's this help. Um, that's check if num plus uh, num plus num plus target num plus num1 num second is equal target. uh, I'm, I think in this situation it doesn't help. Sorting doesn't help because it's gonna take n log n, and we can we can even do O of n using just simple dictionary. So I'm gonna go by idea one. Idea one. So we're gonna create. So we're gonna create the dictionary. In Python, we're gonna use default dict, and then for each or I and num, and I'm gonna use enumerate in Python, which can use a tuple of index and the num together. So first thing is that so check if target minus num is in the set, is in the dictionary. So if target minus num in the dictionary, then we just return so I and dictionary or target minus num, and then else we're just gonna store into the dictionary. So dictionary of I. So actually dictionary of num is the index I. So let's check. Uh, so without sorting, this seems possible. Now, what about cases when it's not sorted? So example two seems okay. How about duplicate? Actually, in this situation, duplicate doesn't really matter. So I think this code is working. Uh, so I'm gonna just submit. Okay, looks good. So this is the like entry question for uh, real interview, and then I guess interviewer is gonna ask. So next, what about the case when we have threesome? So now we're gonna do the medium question as a follow-up. So simulation as a simulation. So this question, uh, if you have arrays of nums, we need to return a three combination of three integers. So as input, we're gonna have array of nums, and then we need to return a list of integers. So for example, Okay, let's do goal setting first. So goal is to return. Are we gonna return index or nums actually? Uh, so in this case, we need to return we need to return combination of numbers, not the uh, not the index. Okay, so we want to return nums where sum is sum is 0. Okay, that's cool. So constraint. What kind of constraints do we have? So let's copy and paste from the previous one. Okay, so nums are not sorted. Makes sense. Duplicates are possible. True. Uh, do we have only one valid answers? No. There can be multiple. Actually, the return data structure defined, so we don't need constraint 3. How about no inputs, no empty nums? It is possible. So empty nums, uh, it's possible. So this means we need an edge case. Actually, I think we can just define as length of nums less than 3 is possible. So why don't we just create as an edge case? So if length of nums is less than 3, then return, just return. Okay, so what approach are we going to take? Uh, we might have multiple ways. So how about for each num, run run toSum. So good things about the follow application is that we can use the base function that we just made as a toSum. So we can use toSum, and then we can define target equal uh, -1 times num, y -1, because we want zero as a sum. Then we already know what's the first number. So if we have -1 times number, that's the goal, right? That's the goal we want. So in the target, I'm gonna define -1 times num, and then for nums, we gonna give I+1. So this is because we don't need current index. Okay. So what's the runtime for this? So for each takes of n, and two sum takes of n square. Two sum takes of n. So in total, this is gonna take of n square, which is good in this situation. But can we do faster? Can we do faster? Well, actually, I think in the lower bound, I don't think we can do it faster than of n square, but we can optimize. Uh, what I think is that we can do the sort, then only for each um, only for each negative number. Uh, so this is because after number being positive, we already covered those numbers when we have negative numbers. So the target of being sum equals 0 means we only need to check one side is a negative side or positive side. So since we need to run toSum from either negative side or positive side. Okay, so we can optimize that. So what's the runtime? So sort takes uh, ob and log n, which is good. Um, then after that, for each num, to some takes of n. Uh, so for each is actually, even this is only negative side. It can be of n. So of n times of n, which is of n square in the end. Um, so, but this is optimized. So I want to do this idea too. So let's do it. Idea two. Okay, so what do we need first? So we definitely need output as an answer. Um, and then we want to avoid duplicates. Okay, actually we should have uh, duplicates input are possible. So as constraints 4, uh, no duplicate. So answer should not contain duplicates. So we need to create a scene as a set, so that we don't need to include duplicate answers. Okay, so let's do. So since we have two sum already, let's just use this. So two sum, I'm gonna use two sum first, def of two sum, and then let's separate as a function. Okay, so two sum has nums as a list of integers, and then we have target as integers, and then what we return. So these are returning indices, but uh, what we want is the nums actual numbers. So we need to do a little bit of modifications. So list of integers. So which means uh, we actually need to return num and target minus num. So that's gonna be, and we also have a multiple answers. So we need to create output as a list. So in the end, we need to return output, and then output dot append. So uh, what I did is uh, instead of returning two numbers, we need to return list as output, because in the end we want multiple answers. So that's what I did actually. So let's do debug one thing. So print output two sums, and then we're gonna type nums as nums of input in three sum, and then target it's 0. So how many numbers can we assume? Yeah, so we have 1 and minus 1, which is good. Um, yeah, so I think this is working. Now what are we going to do is, so we're going to implement this idea to sort. So we need to do the sort. Okay, to do one sort, to do one in the sort. So nums of sort, no key need to define. No key need to be defined because we will only sort by ascending. And then to do two is to, so get list of nums 2, nums and 3. So for I, num in enumerate nums. So we're gonna run. We are going to run. Uh, so num2, num3 list. Okay, num2, num3 list equal. We're gonna use toSum, and then as a target, what is the target? I am going to do -1 times num, and then in the input of array, we're gonna pass I plus 1. Okay, so that's good. And then after getting this list, let's do for num2, num3, for num2, num3 in the list. Um, then we're gonna do the to do 3 check duplicate. So if okay, so if num2, num3 not in scene, and then we're gonna add to the output as a list. Else, so either way, we want to add these numbers. Okay, so question, do we want to add to the scene inside of if statement or outside of if? If it's not in scene, sure, we want to add it. If it's already exists in the scene, we don't need to repeat the adding process. So I'm gonna keep that add inside of if statement. Okay. So now we have output. It's added. Okay. And then we want to break after non-negative. So let's do one thing. So if num becomes positive, because we sorted ascending order, we can break. Okay, and then return output. Okay. Okay, so this is nums, not num. List object has no attribute add. Okay, I need to append. Yep. Okay. So first quick example one seems working, and then let's test the edge cases. First, only one element. Looks good. What about empty array? Looks good. Okay. What if there's only positive numbers? Nice. Okay, can we submit? Nice. Okay, so runtimes. So as an analysis, as I mentioned, this is O of n squared. Because we, although we have sorted, this is n log n, which is less than n squared. So we can say O of n squared, and this is optimized compared to other idea, which is idea one, because we only need to check for negative numbers. So yeah, I think this is my optimized solutions for 3-sum using 2-sum. Yeah, thanks for watching.